Suppose we have function f of x is an exponential function b raised to the power x. Then by definition, the definition of the derivative, we know that any derivative of a function f of x is equal to limit h approaches 0 f of x plus h minus f of x divided by h. This is the formula to find the derivative of a function by definition. But in this case, the function is b raised to the power x. So you can replace this function with b. It becomes limit h approaches 0. F of x plus h means wherever there is x, replace it with x plus h. So it becomes b raised to the power x plus h minus b raised to the power x in simple form and divided by h. On the upper side, you can see both have b raised to the power x as a common factor. So you can take that factor outside, and b raised to the power x has nothing to do with the limit. So you can take it totally outside. So it becomes b raised to the power x here, limit h approaching 0, b raised to the power x is already taken outside, so b raised to the power h minus this is outside, so it is 1 divided by h. So if I say this is equation 1, now
But I have a question. We have studied these exponential in last semester, so why we are studying it again? Like it's something new or?
No, you didn't study the exponential function. There you studied the limits.
Okay.
You did not study these things because we are going to ultimately study the derivatives and integration of the exponential functions. So this we didn't do there. There we have studied the limit. Anyways, now it becomes b raised to the power h minus 1 divided by h. Now this whole guy, if you take it outside, let me consider it separately. Limit h goes to 0 and instead of b raised to the power h, I can write it as 0 plus h minus, instead of 1, I can write b raised to the power 0 divided by h. Now if you compare it with the exact formula, what is the common thing? You can see here, if you compare it with this is the exact formula for the derivative. Now compare these two things. You see b raised to the power, there is x, there is 0, plus h minus b, there is x, there is 0 divided by h. And I told you that this guy is the formula for f dash of x. So the formula for f dash of x involved x, and here this is something which is involving, instead of x, involving 0. So it means this is the derivative formula of what? Of 0. It was x, it was x, so I said this is the formula for f dash of x. It is 0, it is 0, the exact everything is same. It means whatever there is, this is the formula of the derivative for that thing. 0 is also a number. So f dash of 0 by definition is this. So it means you can replace this guy with this thing. So f dash of x is equal to b raised to the power x into f dash of 0. So if you have a function f of x equals to b raised to the power x, an exponential function, then the derivative of such function is equal to the derivative of the function at 0 into b raised to the power x. So, for example, if I have exponential function f of x equals to 2 raised to the power x, then what will be the derivative of this function? What should we do? By definition, I know that the derivative of a function is equal to limit h approaching 0. F of x plus h means 2 raised to the power x plus h minus f of x means 2 raised to the power x divided by h. Is this correct?
Yes.
And in this formula, if I put 0 instead of x, then it will become f dash of 0, and this is equal to limit h approaching 0, 2 raised to the power, this is 0, h minus 2 raised to the power 0, it becomes 1 divided by h. Right?
Yeah.
Tell me if I am doing wrong. Now, if I assume, when we apply limit h approaching 0, it does not mean h is equal to 0. And this discussion is so much frequent we have done that you should already know what does this guy means. When you are telling me h is approaching 0, it means there is a number 0 and the number is h is either coming from the positive side or it is coming from the negative side. The number h is not exactly equal to 0, but it is approximately equal to 0. So if I take any number, suppose 0.1, then I can always say that suppose 0.1 is approximately equal to 0. And if you assume this number h is equal to 0.1 and you are telling me that the limit h is approaching 0 such that h is equal to approximately equal to 0.1, and you put this number into this formula instead of the 0, instead of h equals to 0, you put a very closer number to 0 into this and calculate the values. Now you have applied the limit already. The limit you have replaced with this number. Instead of when we apply the limit h approaching 0, we directly put h is equal to 0. But actually, at h approaching 0 does not mean h is exactly 0. It can be any number which is closer to 0. So you can take, suppose you can take h is equal to approximately equal to 0.0001. So the more closer to 0 you will take, the more good answer you will get. So suppose in this case I am assuming that h is equal to 0.1, and when you put this number in place of h and remove the limit, you get the value for f dash of 0. And for the value for f dash of 0 is approximately nearby to 0.69. So I have got this thing in the formula and I know this function already. So I can now write the derivative of this function by formula. The formula says that the derivative of an exponential function is the exponential function itself into the value of the derivative of this exponential function at 0. So I have already found the value of the derivative of this function at approximately 0 is this. So it is equal to, now this is the function, actually the original function. The original function is 2 raised to the power x and the derivative at 0 is 0.69. So this is the derivative of this exponential function when h is approximately equal to 0.1. When you take h more closer to 0, suppose 0.001, then this value will change. So if this value will change, it means here the multiplier will also be changed. So you will get the more closer derivative value of the function. So everything is basing on this h, which you always assume that it approaches 0. The definition of the number e. So we have seen that the number 2 raised to the power h minus 1 divided by h, and when limit h approaching 0, this number we have calculated just now, 0.69. If you go more closer, maybe you will get 0.7. If you do more better choice for the h, go like this, maybe you will get more better option, but the answer is somewhere like this. Now there is a number and only one number that when you put limit h approaching 0, that number raised to the power h minus 1 divided by h, the same, it is exactly 1. And this is the only guy, e, the value of e, you know. This guy, when you have this formula, the answer is 1. That is why, and graphically this answer is like this. Let me show you the graph. If you have the curves of all the exponential functions, and the curves are going from here to like this, sorry, they cross from 1, so we need the slope at 1. So if we are calculating the slope at this point, and suppose all the curves are trying to pass through this point 1, then the curve of this guy, e raised to the power x, and if we have 2 raised to the power x, and if we have 3 raised to the power x, and we are trying to pass them, this is 0 and this is 1, and we are trying to pass the curves of these functions from this point 1, all the functions, and suppose all other infinitely many exponential functions, and you are trying to pass their curves through this point, then for example, this one curve is like this, another curve is going like this, and another curve is going like this. Then you will see this point, all the curves you are trying to pass them through this point 1. Then you will see that this is the curve that when you find the slope of this curve for this point, the tangent line of this curve, the slope from 1 for this function, the slope is exactly 1. Means the derivative is exactly 1. And no other curve will give you exactly 1 slope when you are trying to pass it from the point 1. So this is the perfect function which passes at the slope of 1 from this point, and this is the guy which gives you a more rapid increase or decrease into the values as compared to the other functions. That is why we say, if this is for example 2 raised to the power x, and this function is for 3 raised to the power x, but this function is for e raised to the power x, then this is the best of all those curves. There are infinitely many curves passing through this point 1, but the only curve e raised to the power x has slope exactly equal to 1. That is why we always, when we talk about the exponential functions, we talk about the e raised to the power x, because this is the only curve which has this value from passing through single point. All the curves when they are passing through one single point. So this is the best of all those curves passing through this line. That is why we always talk about e raised to the power x, and we ignore all others. That is the importance of excellence. If you are excellent, everybody will focus on you and nobody cares who are the others. So try to be more dedicated, more excellent. Understand?
Yes.
So the formula for the derivative. Okay, just now we have calculated the derivative of 2 raised to the power x. Now, can you calculate the derivative of e raised to the power x? If the function is e raised to the power x instead of 2 raised to the power x, can you calculate? Okay, help me here to calculate. What should I do? First step. By definition of the derivative of the function
Right,
x
in the form of
is equal to limit h approaching 0
denote is 0,
e raised to the power
e is x
plus h minus
H
e raised to the power h
minus e power h over h.
over h. So this is the general formula for the derivative of this function. And in this formula, I know the formula to find the general formula for the derivative of exponential function is that it will be f dash at 0 into the exponential function itself, a raised to the power x, whatever the function is. In this case, a raised to the power x is the number e raised to the power x. So my answer will be f dash at 0 into e raised to the power x. So I already have this. I need to find this, and when I will have all this, I will say this is the derivative of this function. No need of this. This is the original function. I need this guy. For this guy, I have a formula now. If I replace the x with 0, it becomes f dash of 0. Limit h approaching 0. E raised to the power x is 0. So it is e power h minus 1 divided by h. And I told you that this relationship is always equal to 1 when you have e here. Just now when we were talking about the definition of exponential. So on the right, this whole thing becomes 1. Therefore, the derivative of the exponential function means the derivative of e raised to the power x is equal to, this is 1 e raised to the power x. So derivative of e raised to the power x is always e raised to the power x. And whatever component you will have with x, for example, if you have b dot x, then the derivative will be b dot e raised to the power b dot x. So the component will come here, just like here. If you have this b, then this b will come outside of this limit. And when it comes outside, e raised to the whatever this guy, then the inside 1 and multiply this, so you get this answer. F dash of 0 is equal. So whatever constant you will have here, for example, if you have e raised to the power 3x, then what will be the derivative of this function? This is the derivative, right? So whatever constant will be multiplied with this, you will get it here, and the function will be repeated because of this formula, because of this rule.
Yeah.
So if we have another function e raised to the power, the function f of x is e raised to the power 10x, and your job is to find the derivative of this function. What should we do? Since this is another function in the form of a trigonometric function, and this is exponent, so we can assume, to make it simplify, just like we were doing in the integrals, you can assume that suppose 10x is equal to u, then this f of x becomes e raised to the power u. Now, according to the rule, what should we do? What is the rule of chain? What is the chain rule? Do you know the chain rule? If I have dy by dx and I want to write it in terms of u,
dy over du multiplied by du over dx.
so both are same. You just multiplied and divided with du. But
Yes.
I have this number. This number is here, f of x. Why? So you can calculate the derivative of this dy by du, because the variable is now u. So your differential will be according to u. And you know that according to the rule, the derivative of an exponential function is the same exponential function. So it will be again e power u. And this guy you can calculate from the supposition. You have u equals to 10x, then du by dx will be the derivative of d by dx of 10x. And it becomes secant square x. So you have this, you have this. Now you can put them into this formula. That will be the derivative of the original function. Dy by dx is equal to this value e raised to the power u, this value secant square x. But u is equal to 10x. So it becomes e raised to the power 10x into secant square x. Okay, now a question for you. You solve it for me. Same. You can apply the same supposition or you can solve it directly. No need to apply that thing, and this derivative is just a recall from the previous semester. So e raised to the power minus 4x sine 5x. What will be the derivative? Means what will be the dy by dx? Apply the product rule of the derivative. Can you do that?
Yes.
Tell me. Here, tell
First
me.
function,
Okay.
then derivative of second.
So what will be the derivative of second?
First we will take the derivative of sine, it will be cos. Then we will take the derivative of 5x again,
Plus.
then plus, then second function same, and the derivative of first
So
function.
what will be the derivative of this function? This guy will come in the multiplier into the function again.
Into function again. Then,
That's it. You can just simplify it.
or we can, I think we can also write it as, first we write it same and then take the derivative of power. It will be the same, I guess.
Yeah, the answer will be the same. When you take the derivative of the power, then it will be minus 4. So you have a minus 4 in the multiplier. And this minus 4 is coming because first you take the derivative of the exponential function, and the derivative of the exponential function is again the exponential function.
Always.
And then you again apply the derivative on this
On
guy.
the power. Yes.
So
Yeah,
that is why it is minus 4 e raised to the power minus 4x.
Right. I think this thing applies on like a lot of things. For example, angles on cosine, sine function.
Everywhere.
Yeah. Like first we take derivative of all and then in the derivative of variable.
integration of exponential function, formula is same. In case of the derivative, d by dx of ex was ex. In case of integral, e power x dx, it is the same e power x plus the constant of integration c. Right? Example. If we have integral x square e raised to the power x cube dx, then what will be the integral? So you see, there is some complications. That is why we use the substitution rule in integrals. So we can assume, you can see how, and now how to decide that which one to choose as a substitution. You can see x square is the derivative of x cube with some constant, and this x square is coming together with dx. So it means the derivative of this guy with some constant is coming here in the downstairs. It means you can assume this guy as the new function u. So if we assume u is equal to x cube, then du is 3x square dx. Now this guy is coming here, x square dx. So I can take these three downs here. It is like this. So this integral becomes integral, okay, like this one first, x cube into x square dx. I have this value, so it is integral e raised to the power, now I have assumed that x cube is u, so it is e raised to the power u, and this value is du divided by 3. So 3 is constant, you can take it outside, so it is 1 by 3 integral e raised to the power u du. This is exactly the formula of integration of exponential function. So it is 1 by 3 e raised to the power u plus c. But u is equal to x cube. So my final answer is 1 by 3 e raised to the power x cube plus c. If we have f of x equals to e raised to the power minus 3x, and the limit is x is between 0 and 1, this will be the definite integral. Can you tell me the answer for this? Same formula, but you have to plug in the limits. Do it on paper and tell me the answer. You are supposed to give me the answer for this. What is the answer? No answer? Just simple. Are you doing it?
Just trying.
What's the answer?
I didn't okay.
Come on.
Confusing.
What is confusing? Don't go to the supposition. Simply directly apply the integral. In case of, I told you, if we have a derivative, for example, e raised to the power 3x, minus 3x. If we have if we want to find the derivative, then this guy will come in the multiplier and it will become minus 3 e raised to the power minus 3x. If we are finding the integral of minus 3x dx, then this guy will go downstairs. So it will become 1 divided by minus 3. This will go in the denominator, and the function again minus 3x plus c in case of the indefinite integral. So here the integral is definite in between the limits 0 and 1. So there is no meaning of c. We will have this limit 0 and 1. And when we plug in the limits, it becomes minus 1 by 3 e raised to the power 1 means minus 3 and 0 means 1. This is the answer. So the difference is, in the case of derivative, whatever coefficient x have, it will come in the multiplier. In the case of integral, whatever coefficient the exponential have with the x, it will go to the downstairs. Same like the formula of the derivative. When we finding derivative of a power function, we said it will go into the multiplier and x will reduce with 1 power. Similarly, in case of integral, we said this guy will go downstairs with an addition of 1 and x will also have an addition of 1. So the same things in the case of exponential, but in exponential the function itself is its derivative, therefore there is no addition or reduction in the numbers. The numbers remain the same. Then logarithmic function, for example, if we write y equals to f inverse of x, then we can write it as f of y equal to x. Similarly, reverse case, we said y equals to b raised to the power x is an exponential function. But instead of that, just like this, if we write b raised to the power y is equal to x, then this appears as the logarithmic definition. Log x to the base b is equal to y, and this is just like same like this. And if this number b is replaced with the exponential number, the best guy, then this becomes log x to the base b, means log x to the base e, which is the exponential number. And this simply means this whole thing we generally write as ln of x. So mostly and commonly we use ln of x instead of, this is equivalent to log of x to the base e. These two are equal things, but this is for all the exponential function we use log. So every exponential function in this way is written in terms of log, and out of all those exponential functions, if we are talking about the number e, then it becomes this guy, and this excellent guy is called the natural log, because ln of e is equal to 1, and these whole things you already know. The important thing is the derivative of ln of x is 1 over x. Now one question, and you have already done this a lot of practice during the advanced mathematics 1 about the derivatives, and we will link the relationship of the derivative of natural log with the integral of the natural log, like with the function going back to the natural log. So suppose we have a function ln of x plus 1 divided by under the root x minus 2. So can you find the derivative of this function? This thing you already know from the advanced mathematics 1, how to find the derivative of this function. So give me a derivative of this function. This is a recall to the last class. Okay, help me to find it. What will be dy by dx? According to the rule, I told you that d by dx of the natural log, whatever is inside the bracket, it is 1 over inside the bracket.
Yes.
So
then again,
whatever is inside the bracket, yeah, then in this case it is dx by dx. So it cancels, we don't write it. In this case, whatever is inside the bracket, one time take it downstairs, and another time d by dx of whatever thing is inside the bracket. So this is okay, but here you know this is just a quotient rule of the derivative. This into derivative of this minus this into derivative of this divided by this guy whole square, simplify, and that is the answer. Now we have another question, and the question says find integral of x divided by x square plus 1 dx. What should we do? Any idea? In the case of derivative, when we have ln of x, the derivative of this function goes down. Now, if we have this function downstairs, and if we can see the derivative of this guy upstairs, then we can replace this whole thing with natural log.
Yes.
So you can see that the derivative of this thing which is downstairs is here missing, some number is missing, but the derivative is here. What is the derivative? If I say this is u, then u is equal to x square plus 1, and the derivative of this guy is 2x dx. Out of this, I have x dx upstairs. So it means this is something whose derivative is available upstairs. So you can simply write this whole thing as, since 1 2 is missing, so if you take 1 2 here, then you need 1 2 like here. You can always do this.
Yes.
Multiply and divide by 2. Now this guy is complete derivative of this guy which is sitting downstairs. It means
Yes.
when we took the derivative of natural log of this guy, it gave me this function. If I have
Yes.
ln of x square plus 1, then what will be the derivative of this? The derivative of this guy will be
1 over
1 over x square plus 1 into 2x
then
dx.
2x. Yeah.
Right? So it means originally the function was this. When we took the derivative, we got this. So it means this thing is a perfect derivative of this thing.
Natural log.
Now if this is a perfect derivative of this thing, means you can write it as
Then replace
1 by 2 integral of perfect derivative of this boy, ln of x square plus 1 into dx. Now these two cancel because a derivative is inverse process of integration. They cancel out. So the answer is 1 by 2 natural log of x square plus 1. Since I don't know what are the values of x, so you simply put the mod on it, because natural log is always only valid on positive numbers. Inside the bracket there should be positive numbers, so you always put the mod on it, because whatever negative you have to consider it positive. A negative, the natural log doesn't work on the negative number. That's why I told you the guy b is always greater than 0 and it is never less than 0. So this is the basic of all the logarithmic, natural log, exponential function. So this b is never negative, therefore the natural log will also not accept any negative. Final thing, maybe you have done it or maybe not, I'm not sure, but we can do it, just a practice. And one question, have we done the Newton's law of cooling problem last semester?
no.
Which class I did that problem?
Not in this one.
The soda bottle inside the fridge, blah blah.
Yes, we did that.
That's what I'm asking. So the same problem, you have to do it today, but today I have written in the notes, but you have to do it again, but with the understanding of all those exponentials and whatever involved over there that time. Remember, there was something involved in terms of e. So you have to do it again.
Yes.
Just go back and do it and see what did you understand from all those exponential stuff. The number e as a limit. Suppose we have function and the function is natural log of x, and this is the given function, intention 1. Now let us start with derivative of 1. Suppose f dash of 1. What will be f dash of 1? By definition, give me the formula. Limit h approaching 0. H approaching 0. Instead of x, I have 1. F of x plus h.
Yeah.
F dash of 1. Give me the definition of the derivative for this guy.
1 plus h minus f of h 1 divided by h over h.
Right, by h. Now I'm saying that the function, in this case we have the function, if I replace, suppose I replace this h with x here in this case, So it becomes limit x approaching 0. Wherever there is h, replace it with x. It becomes f of 1 plus x minus f of 1 divided by x. Now, in this case, this function f of x is the operator ln. So they are same. Both are operating on the variable x. So if the function f is operating on x and this is equal to ln of x, it means you can replace this function f with ln. So you can write it as limit x approaching, because this equation says that both give the same answer. If they give the same answer, then they can equal. So you can replace them. You can always switch between f and ln, subject that they are operating on the x. So here you can, that is why we switched from h to x. Now it is operating on x. Now you can switch it to ln, so it becomes limit x approaching 0, ln of 1 plus x minus ln of 1 divided by x, right?
Yes.
The natural log of 1 is always 0. Good. So this guy cancelled out. And this boy, there is a rule that if you have ln of a plus b, then it is equal to ln of a ln of b. But so far we don't need to plug in. If you remove that, it becomes limit x approaching 0, ln of 1 plus x divided by x. What next? Okay, this is equation 1. Now go back to this function f of x, and this is equal to ln of x. We stop there, that equation. Now this equation means, what is the derivative of this? The f dash of x will be 1 over x. But we need f dash of 1. We said by definition f dash of 1 is equal to this. So we also have f dash of x. If we replace here x with 1, then f dash of 1 means 1 over 1, that is 1. So it means we have f dash of 1 from the direct formula, and we have f dash of 1 is equal to this guy from the definition. But both are f dash of 1. So I can replace this with 1. It means limit x approaching 0, ln of 1 plus x divided by x is equal to 1. Question 2. What does this mean? If you have here you have x and here you have okay, yeah, this guy we can write. Now the second rule, we have this thing, suppose on this, it is 1 by x ln of 1 plus x inside the limit, this guy. Now you know that if you have something a ln of b, you can write it as ln of b raised to the power a, right?
Yeah.
You can always switch them. So if this is here, it means you can write it as ln of 1 plus x raised to the power this guy, which is in the multiplier. You can write this. Is this correct or not?
Right.
Okay. Now, if you have some values for x, for example here, (0.1, 0.01, and the final one is 0.1, and you put them into this function 1 plus x raised to the power 1 over x. For example, pick up x is equal to 0.1 and put this value here. What will be the answer? One plus 0.1, it will be 1.1 raised to the power 1 divided by 0.1. Can you give me an answer for this?
2.593.
2.593. Okay, skip this one. Now use this value, the same formula. What is the answer? What is the answer? This number 7 times 0 into this formula. So it is 1 plus this guy means 1.7 times 0, 1 raised to the power 1 divided by 1 divided by 0.7 times 0, 1. So first find this number and then take the power of this answer as a power of this. What is the answer?
2.71.
1.7 times 0.
2.718.
Anyways, now for the time being, so this is the, so assume this is the answer. So this is equation 3. Now go back, look at this equation. We proved that limit x approaching 0, natural log of this guy divided by this is equal to 1 according to those derivatives. Now this thing I have written here. In this thing, apply the exponent on both sides, and you can do that just like we did with that number r and under the root 3. We applied two exponent on both sides, so you can do this here on both sides. Take both sides as a power of e. So on the left hand side, e power 1 means e. On the right hand side, e power this whole thing. So this is the power of e. Now the limit you can take behind, and this e goes inside. The limit you can take outside, e goes inside. When e goes inside, you know that e raised to the power ln of x is equal to x, because e and ln cancel with each other. So here E and ln cancel with each other, so this becomes limit x approaching 0, 1 plus x raised to the power 1 over x, and this is equal to E. Now this again the same rule that x is approaching 0, it means x is not exactly equal to 0 but any number closer to 0. When you put x is equal to 0.1, you assume that okay, x is 0 approximately equal to this, which I am assuming this is 0, then the answer is 2.593. And when you go more closer to 0, if you assume x is equal to this number, the answer is 2.71 something. And you know the value of E is always 2.71 in general, but we always skip the next numbers, but it never finishes. The next numbers are always there. So it means this is the definition of E, and when we apply the limit on it, it gives us the answer for E. So this is the value of exponential function E. And in terms of limits, you can always write it like this. Limit x approaching 0, 1 plus x raised to the power, whatever is written here, the power will be reciprocal of this guy. That is why you have been doing many examples that when you have some expressions like this in the limits chapter, what you were doing, you were making it like if you have, for example, something like 1 plus 2 raised to the power n, you always try to make it look like this thing, that if you have something here, then the power should be in terms of 1 divided by that thing. If this guy is n, for example 1 plus n, and raised to the power, for example 3 divided by n, then what you used to do, you always used to do 1 plus n raised to the power 1 by n and as a whole power 3. Now you know that when you apply the limit n approaching 0, this guy is equal to E. So you tell me that yes, the answer, the limit of the function is this guy is equal to E and this is 3, so E raised to the power 3. You have used this expression to calculate the limits. This expression is basically from here.